as a heads up, this I bring up a lot. Hey, do you guys remember Alice going for a walk? Do you guys remember that Alice goes for a walk paper? Because this ties together so many concepts of what we're going to do all in one place. So I bring this up a lot. So the graph below shows Alice's distance from home as a function of how many hours she's been walking. So this is her time in hours. This is how far away she is from home. All right, so when, that means you need to give a time, something hours. When is Alice's distance from home 0 miles? There's actually two answers. Yeah, 0 hours and 7 hours. So what does that tell us? Like in context of the problem, she started at home and she ended at home. She's a good girl. She came home. Okay. What was her maximum distance from home? Yeah, 8 miles. When? At time 5 hours. You know how we always write the maximums and minimums backwards? How it's such and such at time such and such. That's the reason we say it that way. Because no one would say 5,8. We don't talk like that. You would say 8 miles and then as a follow-up at time 5 hours. That would be more how that's why that's written backwards. How far did she go total? 16. Yeah. How did you get 16 miles? Because that's correct. Farthest was 8 and then she came back 8. Okay, good. During what interval? And I was kind of saying this if you were listening. An interval needs to be one number to another number. You can't just give a single number. So during what interval did she walk fastest? 6 to 7 hours. So 6 to 7 hours. And what was her speed in miles per hour? 5 is correct. How did you get that? 5. Okay. But think back to Algebra 1. How did you get that? Think like an Algebra 1 student would think. Rise over 1, which we call, you're so close. Slope. Okay. During what interval did she walk slowest? So from when to when? All right. Yeah, what happened to her there? All right, so 3 to 4 hours. And how fast was she walking? Now, she was still going forwards, though. She was still going forwards. How fast did she walk on that time interval? Yeah, 0.5 or half a mile per hour. I don't even know how you would walk that slow. That would be like, I don't even know how you would go that slow. Anyway, what was Alice's average rate of change, which is a fancy way of saying slope, okay, between 0 and 2 hours, and we're going to draw a line. So we're going to connect 0 with 2. And you may have just like kind of done this in your head or estimated or counted the little boxes, but I want to actually write out the points. So we have 0, 0, and 2, 5. So I'm going to list those out, 0, 0, and 2, 5. If you didn't, that's fine. You're like, I did it in my head. That's cool. And then we're going to find the slope between them. So it would be 5 minus 0 over 2 minus 0. Now that would be 5 halves. The other ones are going to come out to decimals though. So what is that as a decimal? Yeah, so 2.5 miles per hour. But what you have to understand is that's an average. Does that mean she was going 2.5 miles an hour the entire time? No, she could have sped up and slowed down. It's an average, okay? Now what we're going to do is bring that in. So instead of 0 to 2, we're going to do a half to 1.5. So watch me point to this. We can all sort of agree. Here's a half. Let's say that hits the graph right about here. Can we say 2.5? 2.5. We'll say that's the point 0.5 comma 2.5. I'm going to write that down. And I'm sorry, I'm not trying to make you seasick, but I have to move the paper to show that. So that'll be our point, 0.5 comma 2.5. And then we have 1.5. Can we say that hits the graph at like 4.75? Can we keep it to like quarters, halves, and 3/4, like to keep things simple? That's usually how I talk my classes through that. Do you see what I'm saying there? At 1.5, can we say 4.75? If you said something different in your group, fine. It's just an estimate anyway. Like we can't find it exactly. But do you see when I connect them, how it's not the exact same slope as this one? Yeah. Like they're not quite parallel. It's a little bit different. Okay. So our other point was 1.5 comma 4.75. So, and I'm going to keep everything to like quarters, halves, and 3/4 for simplicity's sake. So let's go ahead and do our slope. How would we set that up? It'd be 4.75 minus 2.5 over, good. I'll go ahead and tell you as a way of foreshadowing, about half of calculus is slope, is the study of slope. It's a study of change. It's a study of rates of change, which boils down to slope, okay? A lot of times they will in the AP exam ask you for something like this, and they'll say, show the work that leads to your answer. And if you do any part of this in your head without writing it down, they won't give it to you. They want to see all four of these numbers, this minus this over this minus this. It's easy to do, but you can't leave any of it out. All right, so what would we get in the numerator? Think of money, like $4.75 minus 250. That'd be 2.25 over 1, which would just be 2.25 miles per hour. So see, they're not quite the same. All right, now we're going to do one more of those. You know, like how many more of these are we going to do? We're going to do one more. 0.75 to 1.25. So we're bringing it in a little bit further. So 0.75, can we say that hits the graph right around 3.5? Yeah. Can we agree on that? Okay, 3.5. And then 1.25, can we say that hits the graph right around 4.5? Yeah. Like if you connect. Now, when you try to connect those, you kind of can't see it too well, but you know, because it's getting so close together. Also, as we're bringing this in, what does that feel like to you? That should feel like a limit. Thank you. Okay, that should feel like a limit. All right, so the 2 points we got were 0.75 comma 3.5, and then 1.25 comma 4.5. And so again, we're going to find our slope, subtract your y values, so 4.5 minus 3.5. And again, they do this on the AP exam where you have to write that out. Like they want to see that written out. And then it's over 1.25 minus 0.75. Now, let's say you did have to get through that without a calculator. On the free response, you don't have to. By the way, I don't think we've had an opportunity to talk about this yet. On free response, you stop there and leave that alone. You don't touch that. We talked about this a bit in pre-calc. Leave it alone. 2 reasons. Number one, if you mess it up, it's wrong. They will not give you the points. If you have a correct answer and you turn it into an incorrect answer, they will not give you the points. Okay. And secondly, the exam is timed, so you don't want to mess with it. But if it was multiple choice, you'd have to keep going. So what's our numerator? 1, good. And our denominator, 0.5. I'm actually going to write that as a half so you can see it. Dividing by a half is the same as multiplying by 2. So this comes out to 2 miles per hour. Now, number 9, you can't really be wrong because we're estimating. Bless you. Well, I guess if you said 4,000, that would be wrong, you know, but use the answers to the previous 3 questions to estimate Alice's instantaneous rate of change at time 1 hour. So we had 2.5 and then 2.25 and then 2. So as we brought it in, can we say it was approximately like 2 miles per hour? Or you could even say 1.9 if you wanted to be like really nitty gritty about it. But do you see how we brought that in and like we zoomed in on that point and that should have felt like a limit? Okay, so let's explain in our own words the difference between an average rate of change and an instantaneous rate of change. Let's just talk through it. What do you feel like is the difference, like as we were doing these? Go ahead.
Well, average, like a longer data
an instant, good. And I abbreviate these. There are a lot of abbreviations they'll accept on the AP exam, but this one's a Miss Cole one, so probably don't use this one on the AP exam, but I'll let you do this. I do AROC for average rate of change and IROC for instantaneous rate of change. Unless you would like to write out instantaneous rate of change every single time. Anybody? No, we'll do IROC then, and AROC for average rate of change, okay? Average rate of change is over an interval. So it's an average. If I said I went on a road trip for 6 hours and I averaged 55 miles per hour, does that mean I went 55 the entire time? No, I might have gone faster, I might have gone slower, but I averaged 55. Instantaneous rate of change is at one specific time. I'm going to keep going a little bit further before we do our middle of the class break. I want to get these definitions down and then we'll break before we do like some actual problems. But are we clear on the difference? Because that's a huge concept there. Yeah. Interval, it's just an average. Instantaneous is at one particular time, at one particular instant. All right, I left all the space over here so that I could draw a picture. So actually, let's go ahead and do that. Go ahead and draw just like draw a swoopy thing. Draw like an exponential. And I think I drew this picture for you in pre-calc. We just didn't do the instantaneous part of it. This is algebra, this is calculus. I think in pre-calc we did that part, but we just didn't do the calculus part. So here's a point X. On the graph, the output would be f of x. X, f of x. With me so far?
Yeah.
Okay. Now what you're going to do is create an interval. So we're going to travel a distance of h down the x-axis. So if this is x and we went a distance of h, what is this? X plus h, good. And that means the output point on the graph, where we find that on the graph, the output point would be what? F of x plus h, good. It like starts to look complicated, but it's not. Your input is x, your output is f of x. Here, your input is x plus h, your output is f of x plus h. So an average rate of change would be when you connect those 2 points. That is what's called the slope of a secant line. A secant line hits the graph in 2 places. Where you heard this before was back in geometry. I do realize that was 3 years ago, but let me try and jog your memory. Do you remember the unit that you did on circles? And you had a line that went through like that and it hit the graph in 2 places and it was called a secant line? No, that's fine. It did happen. I appreciate you guys being honest, because then I know when you're nodding your heads, you're actually telling me the truth and not just nodding your heads. You were all like, no, we have no idea what we're talking about. Anyway, it's called a secant line if it hits the graph in 2 places. And that's where you did see it before, you just don't remember because it was 3 years ago and it's not super important to your life, okay? So slope of a secant line. So if you subtract your y values, it's going to be f of x plus h minus f of x. That's what'll go in the numerator. You're subtracting these 2. And then in the denominator, I'm going to talk you through this. You would have x plus h minus x. You're subtracting these 2. Now, what's that going to give you? Like the x is canceled, so it would just be h. Does this ring any bells? Because we did do that last year in pre-calc. That's a little bit more recent. Yeah. Well, except for you guys, because that was 2 years ago for you. But anyway, that is what's called a difference quotient. Oh. And you may have seen on the test that you took, on one of the ones I told you to skip, it said find the difference quotient. Did anyone read that? Or when I said skip it, did you just like ignore it entirely? Okay. You didn't even read it. Well, it said find the difference quotient. It means slope. It's a fancy way of saying slope. Okay. Difference quotient. So that's your average rate of change. For an instantaneous rate of change, what you're going to do is basically create this distance h to be smaller and smaller and smaller and smaller and smaller until it's nothing. Let me show you visually what this would look like. If I slide this point down, it's going to look like that. And then if I slide it down some more, it's going to look like that. And if I slide it down some more and some more until it lands right on itself and that distance is 0. That's called a slope of, instead of a secant line, does anyone know what it's called? Good. A tangent line. It just comes by and kisses the graph at that one moment. And you did see that in geometry as well. Maybe you remember that one more. The line just comes by and kisses the circle at that one point. Do you remember that one sort of? If not, it's fine. Like
secant, I was like, wait, is it
secant, and then tangent is just no. Those are the only two. That's a cute question. Slope of a tangent line. It's this exact same thing. This is algebra, but to make it calculus, we're just going to sprinkle a limit on top. It's limit as h goes to what? What do we want that distance h to approach?
Approaches zero.
Approaches zero. We want the distance between the 2 points to be nothing. Its limit as h approaches zero of what we wrote before. The exact same thing. You can copy it over. You might want to highlight that or draw some stars next to that. That is super, super, super important. That is the definition of a derivative. And if you have an older sibling or a friend that's taken calculus before, you probably heard them say derivative about 4,000 times. Half of calculus is derivatives. The other half is integrals, and we'll get to that. They're inverses of each other as a foreshadowing. But half the class is derivatives, so get on board. Because I get some people that are like, no, I'm just not going to learn this. I'm like, no, it's half the class. You like are absolutely out of luck if you don't get on board with this, okay? Oh, and the last thing I was going to say about derivative, just to get you familiar with some notation ahead of time, notation for a derivative, you can see f prime of x, like a little apostrophe, or you can see y prime. It's called a little prime mark. Or the other way you can see it is dy dx. Those are all like symbols that mean derivative. So that's all notation that means derivative. So the first one, we've got f of x equals 5x plus 1. That's our function. A says find the average rate of change from 3 to 7. You can try to do this in your head. And I know some of you are like, I'm brilliant. I can do it in my head. I suggest write your points down because it's not really about intelligence. It's really about staying organized more than anything else, okay? So when it says from 3 to 7, you want a 0.3 comma something and a 0.7 comma something. And don't be too proud to write that down, okay? Because if you mess up something simple, you're going to be upset. Just write it down. So how do we get the somethings, the other parts of the points? Plug them in. All right, here comes like the actual math. 3 times 5, 15 plus 1, good. 7 times 5, 35 plus 1, 36. And then you do your difference quotient. It's going to be 36 minus 16 over 7 minus 3. And on the AP exam, you stop there, you're done. Okay? But for the sake of, I want you to make some connections here. We're going to keep going. 36 minus 16 would be 20. 7 minus 3 would be 4. So 20 divided by 4 is 5. I'd like for you to make a connection between that answer and what's going on. That's the slope. Okay, now it says find the derivative. That's calculus. All right, this is algebra. Now we're about to do calculus. Limit as h goes to 0. Do you have to write that? So that I don't have to write all over your test. Limits, question mark, limits, question mark, limits, question mark. Where are your limits, question mark? All right, limit as h goes to 0. You plug in x plus h. I'm not really a formula person. I'm a poor memorizer. I'm better with directions. So I view it as like step 1, plug in x plus h. So wherever there's an x, you're going to put an x plus h. So it's going to be 5x plus h plus 1. I view it as steps. Step 1, plug in x plus h. Then it says minus f of x. So step 2, minus the function. So minus and put parentheses, the whole function, which is that 5x plus 1. And then that whole thing is over h. Here comes a whole lot of algebra. But good news, lots of things should cancel out. And if they don't, you have done goofed. So you will know if you're right or not, because if nothing cancels, you're going to be like, hey, I lost a negative sign or something. Limit h goes to 0. You're going to distribute the 5. That'll be 5x plus 5h plus 1. And then distribute the negative. It'll be minus 5x minus 1. all over h. 5x's cancel. Very good. What else? Oh, it should be -1. I'm sorry. Oh my gosh, look. See, you know what? I just showed you what happens if you make a mistake. You're going to catch it because you're going to be like, hey, that doesn't cancel. It should be -5x -1. I'm sorry. But I'm glad I showed you that because do you see how I caught it? If you're paying attention, you're going to be like, hey, whoops. All right. So the ones cancel. So you have limit as h goes to 0, 5h over h, and then the h's cancel, and your derivative is literally just the number 5. F prime of x equals 5. Your derivative is 5. Oh my gosh, why is it 5? Because that's the slope. So if your function is linear, the derivative is the slope. And I'm fine with you skipping all this work, but it's only if it's linear. It's only if it's a line will that work. So through part C, what's the derivative instantaneous rate of change at 3? Well, f prime of 3 is going to be, you guessed it, 5. F prime of 7? 5. F prime of -42? 5. Because it's a line and the rate of change doesn't change. It's 5. Okay. Now this one's going to be different. And I actually, oh, I have it correct on yours. 2 square root of x. It was wrong on mine and then I had to fix it, but yours is correct. All right, average rate of change on 1 to 9. Slope. It is regular old algebra 1 slope. Don't be too proud to write out your points because if you mess up an easy thing, you're going to be upset. Plug in 1, what do you get? 2. Plug in 9, what do you get? 6. Set up your difference quotient. It'll be 6 minus 2 over 9 minus 1. Again, on the AP exam, if it's free response, you will stop there. But for the sake of us making some comparisons, I'm going to keep going. That would be 4 over 8, which would be a half. So if it's free response, I want you to stop. Again, because if you mess it up, it's wrong and the exam's timed. So you don't want to waste time doing something you don't have to do. But simplifying is still an important skill because if it's free, or excuse me, if it's multiple choice, you're going to have to keep going till you get an answer. All right, derivative. This is where it becomes calculus. Limit as h goes to 0. Yes, you have to write that. Step 1, plug in x plus h to the function. So it'll be 2 square root x plus h. Plug in x plus h. And then what's step 2? Yes, subtract the function. And then step 3, the whole thing is over h. Now I'll use another color. It won't show up real great. But when you have square roots, you multiply by a conjugate. So your conjugate is going to be this exact same thing, but with a plus sign in between. So I'm not going to read all that to you because that's, that will sound really annoying, but just recopy that, but put a plus sign in between. That feels like a lot to write right there, but everything's going to cancel and it's going to be okay. Like the root ones have that one step where it looks like kind of a mess. But then the problem just sort of disintegrates and you don't really have much left after that. So limit h goes to 0. And let's multiply this all together. 2 times 2. 4 square root of x plus h square root of x plus h is just x plus h. So let me talk you through this. It would look like this. With me? And then that would give you, good, 4x plus 4h. Outsides and insides cancel because one's positive and one's negative. That's the whole thing and the whole point of the whole thing. And then you're going to multiply these. -2 times 2, -4 square root of x times square root of x, x. So minus 4x over, now that denominator, you're just going to leave alone. H times this gigantic mess because there's really just nothing you can do with that. If you start trying to distribute the H, it's just going to be a whole bucket of awful. It already is, so just leave it alone. But something should go away. 4x's cancel. And then after those are gone, what can you cancel? The h's. And so your derivative, you're going to plug in 0 for h. That's the other reason you need to write limit h goes to 0. If you don't, you're going to forget to plug in 0 at the end. Okay? I kind of crossed out a lot of things, but what's still in the numerator? A 4 is still left. And if you plug in 0 for h, this will be gone. So you have 2 square root of x plus 2 square root of x. What would that be together? 2 square root of x plus 2 square root of x. 4 square root of x. Oh, and then actually that'll simplify. The 4's will cancel. And so what would still be in the numerator? 1. So 1 over square root of x. This is your derivative. Hey, Miss Cole, do we have to rationalize that? No, please stop. Please don't do anything else. Okay. Now, instantaneous rate of change at 16. That means you're going to plug in 16 to your derivative. 1/4. So what I want you to notice is, do you see how the average rate of change over this interval was 1/2, but the instantaneous at that one point was 1/4? How those aren't the same? Remember Alice going for the walk as we brought it in? It was different?
Yeah.
Okay, cool. Let's see if I can finish this last one before. No, but hey guys, as a follow-up, what's the instantaneous rate of change at x equals 49? 1/7. How about the instantaneous rate of change at x equals 3? Very good. 1 over square root of 3. And then you would leave it alone. Okay. So I made this one a story problem so we could have something to talk about. A car is traveling according to this function for 2 hours. So your interval is 0 to 2. Time is in hours, distance is in miles, and then it gave us a speed limit. Average rate of change on 0 to 2. Do not be too proud to list out your points. Again, if you mess up something simple, you're going to be upset. So just write it. What do you get if you plug in 0 to this thing? 0. What does that tell you? Like Alice, the car what? Started at like home, I guess we'll call it. All right. Now let's plug in 2. 2 squared. 4 times 25 is 100, but it'll be negative 100 plus 200, which would be 100. So set up your difference quotient. It's 100 minus 2. Oh, excuse me. 100 minus 0 over 2 minus 0, which would be 50. We need units because it's a story problem. Miles per hour. We're going to talk a lot more about this later. A rate of change should always have per in it. It's always something per something else. A rate of change needs per. Got it? Okay. Now, the speed limit was 55, but our average rate of change was 50. Did the car speed at all? It's not enough information, is it? Because they could have sped, but then slowed down enough that they averaged out. So it's not enough information to say yes or no. We need calculus, all right? So we're going to do limit h goes to 0. As a heads up, this one's going to get about this long. So try to write kind of small. And I will attempt to do that as well. We'll see if I can make it fit in on the paper.
We have an instance where h is not 13.
No, because it's a definition. Like this is the definition of a derivative. Its limit is h goes to 0 because you want that distance to be nothing. So that's a really good question. It has to be 0. It can't be something else. Okay. Well, caveat. We're doing the derivative in general, f prime of x. Later on in this unit, I'm going to teach you how to find the derivative at a particular number. So instead of f prime of x, if you wanted f prime of 4, there's a separate definition for that that's different. So there's 2 different definitions, but we're getting ahead of ourselves. So for right now, no, it's 0 all the time. 0. Okay. Limit is h goes to 0. First step, you're going to plug in x plus h. So it's going to be negative 25 x plus h squared plus 100 x plus h. I'm going to just use x. They won't mark that wrong if you change t to x. What's the second step? Subtract the function. Okay, so yeah, parentheses, and just change t to x, just for the sake of simplicity here. I made it fit. Look at that. And then that's all over h. Now I'm going to do this as a side problem on a sticky note. You're going to do x plus h squared a lot of times. So I'm going to show you how it works. Squared means it's a twin. But after this, I want you to kind of just know this one because you're going to do it a lot. X times x. XH and XH is 2XH and then H times H. Okay, that sounded like you guys were with me on that. Now you would need to distribute a 25 through that. Okay, so here's what you're going to have. You can distribute a negative 25. Limit as H goes to 0. And I'm going to distribute a negative 25. So negative 25x squared. And then what? Good. Minus 50xh. Good. Minus 25h squared. There, we got through the difficult part. The rest of this is going to be like we're home free. Distribute the 100 into here. So it's going to be plus 100x plus 100h. And then distribute the negative into here. It'll be plus 25x squared minus 100x. Oh my gosh, I made it fit. Over h. You're like regretting all of life's choices.
Yeah.
But no, okay, look. Pep talk. Lots of stuff's going to go away. Stay with me. You did so well through that. What's going to go away? All right, 25x squared. What else? 100x should go away. And what do you notice about the 3 terms that are left? They all have an h. So we're going to factor out the h. GCF. What's left would be negative 50x minus 25h plus 100. So I factored out the h. H's are going to cancel. And if you're writing limit, you're going to remember that you need to plug in 0 for h. So our derivative is what? Plug in 0 for h. Negative 50x plus 100. Beautiful. I can finish these last 2. That was the hard part. We're through it. These last 2 will be quick. What is the instantaneous rate of change at time 1? Well, you're going to do f prime of 1. If you plug 1 into this, what do you get? So did the car speed? It's still not enough information because that's only the instantaneous rate of change at that one particular point. And what do you want to do? Sit here all day? What if I plug in 1.2? What if I plug in 1.3? What if I plug in 0.9? That's no fun. So we're going to work it out. You're going to take your instantaneous rate of change, your derivative, this negative 50x plus 100. What was our speed limit? Set it greater than 55 and work it out. If you get an answer, that's where the car sped. If you get something that doesn't make any sense, like a no solution, then it didn't speed. What would you do to both sides? Yeah, minus 100, that's going to be negative 45. Divide by negative 50. Do you remember what you do when you divide a negative? You flip it around, and for the sake of time, that's going to come out to 0.9. So did the car speed? Yes. At what times did the car speed? The car sped when? Oh, I didn't flip it around. Yeah. I said it. I'm sorry. That's why you guys are all staring at me. It's because I'm trying to finish it. The car did speed. I said flip it around, and then my hand didn't write it. It sped when times are what? Now you can't go negative, so the car sped 0 hours to 0.9 hours. It's just after that, it slowed down enough that it averaged out to being below the speed limit. Do you see what I'm saying there?